So in this video we will study about the pH scale, and when we study the pH scale, basically we must know what is the meaning of P. So P means that you are taking the negative log or base 10 of the value. So for an example, pH means negative log of hydrogen ion concentration, and POH means negative log, this P is replaced by negative log, and hydroxyl ion concentration, and in big parenthesis means molarity or concentration. pKw is equal to negative log of Kw. So anything P for anything means we are taking the negative log at base 10. So let's see some more example. If P for anything means that if it is written like pKw, we have already seen, and pKa, you may, once you will read some more detail about the acids, you will always know that what about the pKa. You will come with this term many time. So pKa means negative log of Ka, and in general we can write like this one: Px means negative log of x. And if we take the anti-log of this one, or I will say just if we reverse this in the scientific notation or exponential term, then we can write hydrogen ion concentration is equal to 10 raised power minus pH, or we can also write this in this form: hydrogen ion concentration is equal to 10 raised power minus POH. Kw is equal to 10 raised power minus pKw. So in generalize, we can generalize this equation like x is equal to 10 raised power minus px. So these are some important conversions we are going to use when we will do the pH calculation. And pH scale is used to calculate the find out the strength of acid, how acid is strong, how much acid is weak. So pH scale allows us to express the concentration of hydrogen ion or hydronium ion in easier term. So pH is equal to negative log of hydrogen ion concentration. pH scale by 1 for every power of 10 changes in hydrogen ion concentration. What does that means? Just we have seen in the previous slide that basically the pH value is power. pH value is a power of 10, right? So you can see with this equation that hydrogen ion concentration, if one hydrogen ion concentration changes, then it means whatever the pH is changes from 6 to 7 or 6 to 5, it means we are changing in 10 raised power. So pH is a power. pH is a raised power of 10, and for an example, if we are writing like hydrogen ion concentration is equal to 1.0 times 10 raised power minus 7, and if we have written like hydrogen ion concentration is equal to 1.0 times 10 raised power minus 6 molar, right? So pH here will be 7 and here will be 6, and what will be the difference? It would be 10 times change in the pH. So here we can write this in this format, that pH will be equal to negative log of 1.0 times 10 raised power negative 7, and here we can write pH. If we know the hydrogen ion concentration, we can calculate the pH. So this will be negative log of 1.0 times 10 raised power minus 6. Once we will reopen this one, it will come pH is around 7.0 and here it will come 6.0. So pH 7 means neutral solution. We have seen in the previous slides. Neutral solution. If pH is below 6, below 7, it will be acidic solution. And if the pH is above than 7, it would be basic solution. So maximum will go up to 14.0 and that will be the most basic, and below it will go minimum 1 and that will be most acidic part. So lower pH means acidic strength and higher pH means basic strength. Another, if you will see the scale of the pH, so scale of the pH would be like this one, 0, basically you can go 1, 2 or 0. So 0 to 14, so below 7 acid and they have hydrogen ion concentration more than 10 raised to power minus 7 and hydroxyl ion concentration is less than 10 raised to power minus 7. pH 7 means neutral solution, and pH above than 7 will be considered as a base, and in the neutral solution the hydrogen ion concentration and hydroxyl ion concentration will be equal 1 time 10 raised to power minus 7 at 25 degrees Celsius. So this is the about the scale of the pH, and let's see some more math related to the pH. If we have seen this in the auto ionization, so this is the water dissociation constant for water is written as hydrogen ion concentration, the product of hydrogen ion concentration and hydroxyl ion concentration, which is equal to 1.0 times 10 raised to minus 14 at 25 degrees Celsius. This is true at this temperature. This value is true at this temperature, but this equation will true for at any temperature, but the value will change. And so now we can write like this one, that hydrogen ion concentration and hydroxyl ion concentration product will be 1.0 times 10 raised to minus 14. If we will take the log 10 on both sides, so log 10 parenthesis of this product equal to log 10 and parenthesis of in parenthesis 1.0 times 10 raised to minus 14. Once we will open, so log will, once we will multiply, basically it will be plus log 10 hydrogen ion concentration and plus log 10 hydroxyl ion concentration, and then once we will take the log 10 of 1.0 in time 10 raised to minus 14, it will come minus 14. And if we will take negative on both sides, if we will take negative on both sides, so negative on, so basically this is the log 10 and hydroxyl ion concentration is a pH, but it should be written as a negative, and this will be negative PaOH and 14. So basically once we will take negative for everywhere, this will become positive. So we can also write that pH and POH is equal to 14. So this is another way to calculate the pH. If we know the POH, we can subtract from 14, and if we know the pH, we can subtract from 14 to get the POH. So next is a significant figure in log calculation. So rules for significant figure: the number of the decimal places in the log pH is equal to the number of significant figures in the concentration. So number of decimal places is here 1, or we have 2 significant figure, and so okay, so here is this one, number of decimal places in the log pH. So pH value, if it is written in 2 decimal places, so we have to write the hydrogen ion concentration in 2 significant figure with 1 decimal point also. So this is the math for the log when we do, and let's see few examples more so that we can understand a little bit more how to calculate the pH. Find the pH of the solution with hydrogen ion concentration is equal to 1.3 times 10 to the minus 5. So what we can do, hydrogen ion concentration is given here 1.3 times 10 to the power minus 5 molar. So what we can do, we can take a negative log. pH means negative log of hydrogen ion concentration. So we can take a negative log of 1.3 times 10 to the power minus 5, and when we will take a negative log of hydrogen ion concentration in the calculator, so the value will come 4.89, and so pH will be equal to 4.89, or we can, if we want to, because here there are 2 decimal points, so we can write in 2 significant figure. So this solution will be acidic or basic. Basically pH is below 7, so this solution will be acidic solution. So this is the way we can calculate the pH of this concentration. Let's see the another example. Find the concentration of hydrogen ion in the sample of the lemon juice which has a pH of 1.9. So now they have given already pH. So pH is equal to 1.90, and what we can do, if you remember the previous formulas, pH is equal to minus log hydrogen ion concentration. So there are 2 simple ways to calculate this, and if you take if we want to calculate the hydrogen ion concentration, we can do like this, 10 is power minus pH. So from here we can find out the hydrogen ion concentration. So what we can do, hydrogen ion concentration will be equal to 10 raised power minus pH, and 10 raised power minus, rather than pH we can replace with this value 1.90, and once we'll take 10 raised power minus 1.90 from calculator, when we'll calculate, it will come around 1.3 times 10 raised power minus 2 molar concentration. And is this solution acidic or basic? So basically pH is below 7 and it is very close to 1, or it's around 1.9. so this is very acidic solution. What would be the concentration of hydroxyl ion for this sample? So what we can do, it's very easy. We can use the this formula which we have seen, pH plus POH is equal to 14, and then POH will be equal to 14 minus pH. So 14 minus 1.90, and POH will be 12.10. So this is the pH. pH. No, sorry, this will be POH because we are calculating and we are subtracting pH. So this will be POH here. And if we know the pH, we can calculate the hydroxyl ion concentration OH ion will be equal to 10 raised power minus POH, and 10 raised power minus POH means 10 raised power 12.10. Once we'll solve this, we will end up 7.9 times 10 raised power minus 13 molar. So this would be the concentration of hydroxyl ion. There is one more way to calculate the hydroxyl ion concentration from this value. So as you know that Kw will be equal to hydrogen ion concentration plus hydroxyl, and not plus, this is multiplied product, and hydroxyl ion concentration, which is equal to 1.4 time 1.0 time 10 raised power minus 14, and we know the hydrogen ion concentration, so we can rearrange this equation. Hydroxyl ion concentration will be equal to 1.0 times 10 raised power minus 14 divided by hydrogen ion concentration. And hydrogen ion concentration we have already calculated, so 1.0 times 10 raised power minus 14 divided by 1.3 times 10 raised power minus 2, and once we'll solve this in the math, in the calculator, it will come 7.9 10 raised power minus 13 molar. So whether you can use either this formula or this formula, and answer you will get the same. So here I would like to show you one interesting thing, that if we know, using this chart, if we know the hydrogen ion concentration, we can take a negative log of hydrogen ion concentration, and then we will reach to the pH. If we know the pH, we can subtract from 14 minus pH, we will end up the POH. And if we know the POH, we can take the 10 raised power minus POH to calculate the hydroxyl ion concentration. So this scale is very handy, and you must remember this formula. So this conversion is very important to find out. And here is some strength is given, like milk, saliva, rain, black coffee, tomato, wine, cola, vinegar, and lemon juice, and stomach acid. So you can see stomach acid is too much acidic than milk. And in the summary, we can summarize that pH is negative log OH, and hydrogen ion concentration is 10 raised to minus pH. POH is equal to negative log of OH. And then this is one summary, and then one more summary is here. You can use either this conversion, how to convert the hydrogen ion to pH, pH to POH, POH to hydroxyl ion concentration, and so you can use this conversion also. I would like to show you one more slide, that measuring pH, how we measure the pH in the lab. We usually use pH meter, and there are some pH indicators which we use to find out what is the concentration of hydrogen ion and hydroxyl ion concentration. So there is in case of pH indicator, there are some important pH indicator, that methyl red, what are the range of methyl red? It show the conversion from 7 pH is yellow, 2 is acidic is red, and then bromomethyl blue is yellow in acidic and basic in the blue, and then phenolphthalein is purple in or pink color and the basic condition. So these are some important pH indicator and their range. You have to memorize this one, or just remember you will be use this one. And in the next video we will study about the strong acids.